All right, everyone, this video is a response to one of the questions I quoted as a formative assessment, saying, hey, try this, KSP solubility question. From the response that I got through the Google Classroom and emails and whatnot, I had a wide variety of very interesting answers. And so I thought it would be best, instead of answering each person directly, that I would show you the proper processing, or even just the thought process itself, not even just the calculations, so that you would be more clear of your expectations in the future. I'm going to go ahead and create a little chart for myself, because after all, if there is a precipitate, this is going to involve moles, concentration, so on and so forth. Okay, so first and foremost, before we begin, you would have some information through the data sheet on the Google Classroom that this is going to be my potential precipitate, that any compound that has a nitrate is going to always be aqueous, very, very polar, very, very soluble ionic compound. So using the data sheet, the KSP of silver sulfide, is going to be 1.6 times 10 to the negative 49. Very little. It's virtually close to a zero. But anyways, we don't need that right now. Let's keep going. For the sake of formalities, I really appreciated people who didn't just take this for granted, but decided to actually test the actual solubility by calculating Q. Now remember, Q is going to be a trial run of the solubility product constant, Ag plus, and that's a 2. Why is it this way? Well, simply put, I'm going to put it all the way up here. The K value is a result of the concentration of sulfur ion and the concentration of silver ion in the reversible reaction. Oops. There. Okay, that would be aqueous, and that would be aqueous. So you see that this product is a numerator, and it will be a denominator of 1, simply because we do not put a concentration for a solid. All right, so if I were to test this right now, if I simply plugged in the concentration of concentration of sodium sulfide and silver nitrate, I would have to quickly calculate that. The new concentration of sulfur would be concentration times volume divided by the new concentration, which would be approximately 0.03. Repeating, the concentration of silver would be the initial concentration of silver multiplied by the volume, which would get me the moles, divided by the final volume, which gives me concentration to be 0.0006. Repeating. So taking all of these and plugging it in, I would get a Q value that is much larger than the K value of 1.6 times 10 to the negative 9. Therefore, AgNO2S will precipitate. Okay? Good job on that part, right? Going through all the motions and being very thorough with it. But the idea goes on further. In fact, this number is so small, I'm actually going to test right away how much sulfur and how much silver actually will remain dissolved. So how about I use a different color to show that this is a different part of the calculation. So I will say, in fact, in blue, okay, the KSP of silver sulfide is going to be some concentration of, remember, if this is being produced, some concentration of silver, sorry, so of sulfur and some concentration of silver, right? If you have no idea what the heck I'm talking about, I am using this, or rather I am using this as my template. For every 1 mole of sulfur, I would produce 2 moles of silver. Okay, and if I were to work that out, that would become 4x to the power of 3, x therefore 1.6 times 10 to the negative 49 divided by 4, cube root. This would be 3.4 times 10 to the negative 17, which is essentially equal to a 0. This number is super small. Practicality purposes, you wouldn't see anything being dissolved with the naked eye. Okay, so you can safely assume all reactant present in this question, in other words, 0. whatever moles or 0. whatever moles, all of it is going to react. So it will produce a until the limiting reagent runs out. So this basically becomes a grade 11 question. I am going to go about with a different color. Start working out how many moles of sodium sulfide I have, how many moles of silver nitrate I have, so that I figure out how many moles of the silver sulfide I'm going to produce. Okay, so very quickly, moles is equal to concentration times volume, N equals CV. That's going to be 0.01 moles. N equals CV. This is going to be 0.0002 moles. Which one is a limiting reagent? Let's see. Well, this uses twice as much. I'm going to assume that you know how to calculate limiting reagent. The limiting reagent is going to be that number. So I'm going to use that for my mole ratio. The number of moles of silver sulfide to the number of moles of silver nitrate is 1 to 2, which means how many moles to 0.0002? X is going to be 0.0001. So how many moles is that? Sorry, how many grams is that? Therefore, if the number of moles is equal to 0.0001, the molar mass of silver sulfide is 2 times silver 0.87, I think, plus 1 sulfur. That's going to be approximately 247.8. Did I get my... Give me a second while I plus that periodic table. Silver is 0.87 and sulfur is 32.07. So this is going to be 2 times 107.87 plus 32.07, 247.81. The mass, therefore, would be approximately, using sig figs, I can only have one sig fig, 0.0248, which is approximately 0.02 grams. Okay, hope that helps. There's a lot of people who went about this in a slightly different way. If your calculations are a little bit off, please question me and ask me why the way you did it wouldn't be viable or not. But I do hope that this helps. Okay, keep working at it. I really appreciate your initiative and your continued practice. Don't let up just because no one else is really watching you. Pretend you're just doing the exact same thing, but just far away. Okay. Yep. Good to hear from you all, and keep working at it. See you soon.